to whoever this may concern. My name's Anas Samadi, user ID W1778273. This is my final year project. It's called Starbucks Customer Data. It's based on this data I obtained from Kaggle, which belongs to Starbucks, and the purpose of this project is to analyze the data, pre-process it, wrangle it, and the results required, I'm going to put it into an interactive dashboard. To start off, this is my file. First things first, we're going to go through the actual code, which is Starbucks Customer Data, and I'll walk you through the rest of the notebooks later. First things first is, since my project is based on Jupyter Notebook and it's not like a website where I have to go through every button, so in this recording I'll just briefly go through the analysis, and when it comes to the dashboard I'll break it down as much as I can, but for further explanation I'll do that in the Viva. So first things first, load the data. I wanted to restart the kernel so I can show you everything from scratch. Okay, in this process we're just inputting the three datas that I've required. It's not only one. The datas are the profile, the portfolio, profile, and transcript. This stage we're gonna go through data analysis where I'm gonna wrangle, pre-process, clean and the data. So first things first is show the data. The first step of pre-processing is drop the unnecessary columns, which is the ones with the value unnamed 0. We're dropping them. Alright. This is where we start the cleaning and wrangling. Alright, so we can see the profile dataset here. Each code will have its own comments, and that is for the viewer to have a clear readability. Alright, in this stage of the code we extract unique channels from each channel column and creating new columns for each unique channel, indicating its presence in absence, and this is for the portfolio dataset. Okay. Okay, let's find any ID in the portfolio listed. So what we're doing here is looking for IDs. This code helps us identify any common ID values between the portfolio and the profile data frame. So what we have here is became a member on. This became a member on does not really help us. So what we do is we look for the date each person became a member on. Okay, once again we count the null values for gender and income. In this section, alright, okay, in this section, let's see what we're doing here. We drop any, okay, since income and gender are very important variables and both have corresponding null values, therefore there is a need to drop any rows containing null values, which is what we're doing here. Okay, this code shows us that there are no duplicate records in the profile dataset. The profile dataset is now cleaned and ready for further analysis. The next stage, we re-index it and get its final look, which looks like this. Become a member on seems to be an array which contains unique distinct value, like this. Let's find out and drop it. So what we mean by this is two members or more have similar unique values. What we need to do is drop them values because they are unnecessary. Okay. Transcript.head, it just shows the first 5 rows of our cleaned transcript dataset. Transcript.shape shows us rows and columns. Alright, in this part of the code, the transcript dictionary, we find what they contain, their key, which we call it. The purpose of this is to extract all the unique keys from the dictionary presence in the value common transcript district. So what we do here is extract values into dictionaries and store them into a list. As shown in the results below. Hold on. There is author ID and author underscore ID. This can be a bit confusing. So what we do here is, because these two are similar keys, we need to merge them into one. This is what this code is for. We change the author ID to author underscore ID, confirm changes, which remains author underscore ID. This is still all part of data pre-processing and cleaning the data. This part of the code shows the complete data set, and for the transcript we're still looking for null values. Okay, this code shows that there are duplicate records in the transcript dataset that needs to be removed. They will be removed while keeping the first row, the first one. This will affect the index but will be fixed by reindexing the dataset. So we drop the duplicate records, reset the index and confirm the operation. Alright, from this stage on, all 3 dataset has been cleaned, pre-processed and wrangled. So what we do here is we start the data visualization. Data visualization is a key process in my project because it's what the users are looking for. It's how they understand the data instead of a bunch of codes that, if they're not really technical, they wouldn't be able to understand it. So this part of the code is going to show us outliers for ridiculous values in the age and income features. I'm going to show this by plotting a box plot. Let's run the code. Okay, this code just I am inputting the values for the plot. It's based on the profile data because it contains age and income. No, it contains age. However, the transcript is where income comes in. This code is just displaying the plot, the color, size, etc. Outlines of the data. The first 2 shows the profile data of age and income. As shown here, there are no outliers as in ridiculous values because the data is already cleaned. We can see that for age, the maximum age is around 100, maybe 101, and the least is around 18 roughly. And the middle part shows us what is the age gap in the age sector. And for the income, similar thing. It shows us the highest income is 12,000, and for the least income would be just about 30 to 20,000 to 30,000. Okay, the transcript data, it shows us just about the highest is maybe 710 and the least will be 0. This box plot shows that there are no outliers in the dataset and is ready for further visualization and modeling. For this part of the data, we save the data and prepare it for the next section of the code. The clean data we have here is going to be needed for the other part of the code, which I'll show you in a minute. This is where we start the RFM analysis: recency, frequency, and monetary. Alright. First, we start with the transcript dataset. As we know, RFM analysis focuses on when the customer brought goods. It can be based on how recent, how frequent, and the monetary, how much. So, first things first, the transaction. The transaction shows us that the time is 0. This is not really understandable. What they mean by time is when they come, the day they came. 0 means very recent, very frequent. Because time, it can't mean seconds or minute or hour. It just doesn't make sense. So in my calculation, times mean when they recently came. What we're doing here is analyzing the recency, looking for a minimum of each customer. The last transaction, how recent they came. So let's carry on. Okay, this code above shows us this person ID came 228 days ago, which means just about a year ago, and shows you when each person by their ID when the last time they came. Okay. And this is where we start the frequency. As we know, frequency is who has purchased frequently, as in who purchases frequently. It means like the total number of purchases for each customer. The higher frequency, the better. So this code below is going to show us the number of times each customer appeared, how frequent they come. Alright, so we can see that this person's ID has a frequency of 36. Okay. This section of the code, we are merging between recency and frequency. It shows how recent the customer came and how frequent it is. The monetary value. We know that the monetary value is the amount purchased. The higher the monetary, the better. It means the total money customer spends. In this part of the code, we are getting the transaction value, put it on the dataset, verify the operation. What is shown here is this person has a monetary value of 0.83 cents, which means he bought something cheap. Could be a snack or whatever. However, the second person has a monetary value of 34.56. This customer should be more valued because he spent more. Because it's a Starbucks, he could have bought something for family or whatever. What we're doing here is calculating the total amount of each customer spend and append the RFM data. Same process. Each customer, we are seeing total amount spent. And for this, where were we? Okay, for this part, we are merging between all three of them: recency, frequency, and monetary. This gives us a bird's eye view of each customer's value. Alright, for this part of the code, frequency and monetary values were divided into 5 pentiles. The pentiles were named from 1 to 5, where 1 represents the first priority and 5 represents the least. This shows us, it depends for each RFM analysis, recency and frequency. So recency would mean 1 is represents the most prioritized and 5 is the least prioritized, but it's different for frequency and monetary. This is how a user will be able to see it. If person 7A has 1, 2, and 1, that means he's a regular customer. All the pentile labels were merged into a single string called RFM score. The customer having RFM score of 555 were best since the most recent, most frequent, and most spent on Starbucks. RFM pentile. Okay, in this code, it gives us the total score of what we basically just calculated. This code below shows us from least to the highest. Alright, that is RFM done. Now we move into k-means clustering. K-means clustering is an unsupervised machine learning algorithm. In this analysis, customers will be clustered based on the monetary, age, and income. The spending score will be calculated for each individual customer. The spending score ranges from 0 to 100. Okay. First code. We're calculating the spending score. What we're doing here is filtering the data. Profile.head, as we said, shows us the first 5 rows of the profile dataset. Now we merge to find how each customer on the profile spends. Income and spending score. The income and spending score dataset will be filtered. The X income data will be clustered in cluster range from 1 to 11 to find the optimal clusters. A line graph will be plotted and the elbow graph will be found in the line chart. This code below, we are going to perform the elbow method to determine the optimal number of clusters in k-means clustering. Okay, this code shows us clusters from 1 to 11. And it shows this cluster is for the range of income, by the way. So we can see that the graph is started to stabilize around 3, which means that is our optimal cluster. Yep. Cool. Let's now find the cluster centrals. Cluster centrals. Attribute contains coordinates of the cluster centrals, or in another word, centroids of the filtered k-means model. After fitting the customer k-means model, X income data will be clustered into 3. Let's visualize the clusters. This graph is a scatter plot that shows us the spending score and income of each customer. As we can see, it's clustered into 3 sections. Between 0 to 60,000 is yellow, 6,000 to 8,000 is about red, 8,000 to 12,000 is about blue, and we can see that the most spent is the blue section. And the plus we see over here, that is the centroid of the k-means. All clusters exhibit the same behavior, however the blue clusters have spending the most, between 8,000 to 12,000. Okay, we do the same method for age and spending. Earlier we calculated for spending score and income, now we're calculating for the age and spending. Alright, what we're doing here is, okay, same method. Now we're going to check the elbow method for age and spending. Alright, so what we can see here is, again, it's clustered between 1 and 11. That is to find the optimal cluster. This graph is going to show us the optimal number, which again it's number 3, as that is where we see the line starts to stable. 3 is just about here, so that's where the line starts to stable. Again, same method, and this is where it shows us the graph for the spending and spend score and age. As we can see, the age starts about 18 years old to 41 is pink. It's divided into 3 clusters, about 42 to 62 blue, 62 to 100 yellow, and as we can see again, yellow has the most groups. Scatter plot shows the yellow cluster had the highest spending score. The yellow cluster included the age groups but is most dense around the age of 60. That is it for the analysis and pre-processing. This is where I included RFM and k-means, and I'll be showing you the next stage of my project, which is the dashboard. 2 of my project is the data visualization section. This is my second notebook, which is the visualization profile. What we do here is, again, import the necessary libraries, load the dataset. In this section we're only going to need the profile dataset. What we do here is comparison, where we compare the gender and income. We're going to do this in a box plot format. This section shows us the gender of female, which is, we got just about 70,000. The gender of males is just about, that looks like 61,000. And for O, I believe it stands for other, which is any other gender. I don't know. That is what the data set shows me. Okay, what we do here is find the unique values, which we got. It even states the exact number of males and females. Age group and income, same thing. We do the comparison for age and income. What we do here is create a new age group. Bins, it just clusters each category in its own segments. We have from 18 to 36 as youth, 36, 56 is middle-aged, 56, 76 retired, and 76, 150 is aging. This data frame, once we run it, it shows us another box plot which shows us the income of each of the 4 categories. We got youth's income just about 50,000, middle-aged around 61, retired about 70, and aging just a little bit above 70. Composition. This part of the code is where we create a new age group. Again, we label it by bins, which is clustering it into 3 segments. Which is their income, which 10,000 to 30,000 is low income, 30,000 to 90,000 is middle income, 90,000 to 20,000 is high income. This plot shows us the same thing, which low income, I don't know what it shows it, like very low, but we can see that the middle income is just about 60 and high is just about 100,000. Okay, this is ID and age. This is where we plot the sunburst pie chart, which I've went through in my report. The sunburst pie chart shows us a unique visualization of this nicely formatted circle, which shows us the 3 genders that we have: female, male, and other. It shows us for each aging their counts, how many there are, their gender, and income status. It shows the same thing for females and so on. Once we click on the specific gender, it gives you a clearer view of it. Once we click again, we can go to male and it shows us the same thing. This circle in the middle represents the income, which opens up this little segment, and once we increase it, it shows us the income sector. Here we have for the female segment is divided into 3: aging, middle-aged, and retired. Once again, it shows us the retirements counts, gender, and income status. And again, once we click on it, it gives us a clearer view of it. It's quite unique. And that is it for the visualization part. Last but not least, we got the dashboard part of my project, which in my case is the most fun and interactive part of this project. So in order to open it is we simply open the notebook. This is where it opens the notebook. You might ask yourself, why do I have 3 different files for one project? Well, first things first, the Starbucks customer data, which includes the processing, wrangling, and cleaning, and k-means, RFM, and whatnot. I wanted to keep this in one notebook. It's just part of the organization. And regarding the visualization, again, I wanted to have it all in one notebook, part of organization, and dashboard in a separate one. However, I did have some complication with sunburst pie chart. I tried importing it into my dashboard, but I was getting some errors. But then I found out that the library for sunburst does not support HV plots, so it just wouldn't come along and work together. Anyways, let me show you what I've accomplished in the dashboard. Okay, first things first, load the requirement libraries. And that may take a minute. Alright, cool. So what we do here is, if you can remember, we loaded the relevant data. This has already been cleaned, like I've said in somewhere around this code. I've cleaned it and processed it, and I've saved it just above. There it is. So this, we have loaded it into the dashboard section. We just run a little process in here for last definition. It's the same method we used for our visualization, a bit of clustering. We extract the transaction data only. For this part of the code, we are retrieving amounts from the value column. Alright, so in this part we have found there are a ridiculous amount of outliers in the sales amount. This is not good. So what we do is we simply remove those outliers, and that is done by importing this box plot, which gets rid of all the outliers. Alright, so what we do here is retrieve the rewards from the transaction only, because rewards is what we're gonna need for our dashboard. Mouse. Okay, for this part of the code, we are merging rewards and sales amount into a single data frame. What we do here is the sales variable extracts the sales amount column from the data set, and reward, it does the same thing, extracts the reward column from the reward data frame and converts it into rewards. We then fill the reward with null values. What that does is calculates the difference in length between sales and rewards. Alright, and then we just create the data frame and display it. This part of the code, we are setting an environment for the dashboard, hvplot. And this is where the aesthetics begins, where I carried on creating the dashboard, implementing the right adjustments, color coordinations, and etc. It should be pretty straightforward. I've just imported the necessary dataset here, same here and here as well. This is where I played around with the panel, just made I was playing around with the widgets. This is for the sidebar, which you'll get to see the final results in a second. This is all part of the modification. This error is safe to ignore it. I will be going through the coding in more details in my Viva, as mentioned by my supervisor. Okay. I'll be going through the graphs and the buttons and panels in a second. And this is where the fun bit begins. In order to open my dashboard, I simply have to run panel serve dashboard in my local host. This section has caused me a bit of a headache because I've tried figuring out why the loading takes forever. However, I ended up figuring the issue. I simply have to open up my local host, This should work safely with any other machine. As you can see, the loading is still taking forever. There are two methods to opening this dashboard. Either opening this specific link, or by importing my IP address, which is 127.0.0.1 http.1. I'll show you in a second. Anyways, this is how my dashboard looks. HVPlot comes with the support of night mode, which is a unique way that I also liked about it. Alright, first let's go through the features of HVPlot. The functionality of HVPlot. So we got here is the actual pan where you can interact. This is to zoom in, which we won't be needing. This is to save, quick button to restart the operation, and this is to hover. Cool. So now let's go through the actual scat plot. The scat plot shows us the relationship between the reward and difficulty, which we have over here, rewards and difficulty. This plot shows us the reward for buy one get one free, discount, and informational. Let's say we want to focus on buy one get one free. We deselect the discount and information, which leaves us with these two plots. Alright, so what we see here is the offer type, buy one get one free. It is in between 4 and 6, which is 5, as well as difficulty 5. It's an average offer, and the difficult the offer, the higher the reward, which is in this case is 10 on each. If we deselect discount, same thing applies to it. It's just the between 5, so discount 5, difficulty 20. What they mean by difficulty is, as shown in my dataset, if we go to the profile dataset, there it is, difficulty. So difficulty can mean how hard it was to reach the customer. Could be by email, mobile, social media, whatever the dataset requires. Back to my dashboard, and last but not least, informational. Informational could be like personal discounts or whatever. This is all the way at the bottom, which says that the customer received nothing over here. However, if we change the reward to difficulty, it becomes, no, if we change difficulty, we have to change this to durational, which durational means, go back, durational over here, it means how long it lasted. So let's have a look. We have the discount is around 20, so the duration, it only lasted for like 10 minutes, but it was hard to get, which is all the way at 20. Same as shown in the rest of the plot. Anyways, you get the gist of it. I've purposely changed each discount or offer in different colors. That's for the user's easy readability. And next up we have the profile bar chart. This is based on the profile dataset that we obtained from Starbucks. This dataset shows us, if we can just restart it for the best view, it shows us the demographics between gender and age group. As we can see, female is about 70k members, male about 60, which we already explained, and other. It also shows the income on this right hand side column. Okay, and if we by a click of a button we can change the demographics. As we been through in the visualization notebook, we have youth, middle age, retired and aging. For youth, as we mentioned, it was about 18 to 26 as far as I remember, and their income was just about 50k. And for middle age, it's about 64, retired 70, and aging 71. Again, this is a nice and easy way for the user or stakeholders to view or understand the dataset without having to go through the whole code, and this is if they were non-technical. Again, it shows you a detailed progress of the datasets on the right hand side. And lastly, we have the distribution of sales and rewards. This is for the transcript dataset, I believe. Okay, what we are shown here is the reward and sales bar chart. For sales, we have a total of 26,000 for the highest, 30,000 for the next highest, and so on and so forth. This dataset shows us also rewards. If just by a click of a button you can change the rewards. So what is shown in this dataset is rewards. A customer gets around $5 on average as a reward. That could be any of the discount, buy one get one free, whatever. And the lowest is about I'm assuming that is $3. Also, if we go back to sales, we can see that the highest spent is about $1.0048. This, I'm assuming it could be coffee, tea, because that's the range that specific product cost, and it is the highest, which makes sense because this is a dataset for Starbucks. And the least and the most highest purchased is around 11 per customer. That could be a whole meal, a meal for two, it could depend. And that is my dashboard discussed and finalized. I hope you enjoyed and understood my project. For any more clarity or discussion, I should be available for the Viva and explain it more. Thank you for tuning in, and goodbye.